All right, here we are at the end of the 7th week. This is day 14. We're going to pick up where we left off, section 2 of chapter 3. Solve this equation, 3x squared plus 2x equals 7. Which method are you going to use? What are the three methods we know? Quadratic formula. What's another one? Complete the square. And then factoring. Very good. Factoring only works if it's easily factorable. Complete the square works, but it gets complicated whenever your B term is odd, because then you'll have fractions. Quadratic always works. So the first thing we have to do is make this equal to 0. So we have to subtract 7 from both sides. Because we're looking for the x-intercepts. So we have to set y equal to 0. Then we have to label A, B, and C. What is A? B, and C. Very good, -7. And we're going to use the quadratic formula. You don't have to, but I always suggest always start off by putting down the formula so you at least memorize it as you start going through. Now from here, it's plug and play. Negative B is 2. B is 2 squared. 4 times 3 times -7. Believe it or not, this is where most of the mistakes happen. By putting the numbers in the wrong place or putting the wrong number in the places. So that's why I label them. B is 2, B is 2, A is 3, and C is -7. So what do you do first? Inside the radical special operation, we have to do the squared first. 2 squared is 4. And then on the bottom, 2 times 3 is 6. So we have negative, there's 2 negatives in this equation here, so it's going to be positive. 3 times 7 is 21. 21 times 4 is 84. Inside the radical, 84 plus 4 is 88 over 6. Now what do you do? Look inside here. The only thing we can do right now is what can we do inside? What is 88 made up of? 8 times 11. 8 is made up of 4 times 2 We have a pair of 2s. So what can we do with that 2? Since we have a pair of 2s inside here, 88 is 2 times 2 times 2 times 11. Since we have a pair of 2, they come out. 2 times 11 is 22. You look for a pair of the same numbers, and whatever pair you have, that comes out. Now, since we have even numbers on top and even on the bottom, what can we factor out of the top? Only the coefficients. We take out a 2, which will leave us -1 plus or minus square root of 22 over 6. Since both of these have a 2 in common, I can pull it out, 2. That leaves me -1, and this is so square root of 22. 2 goes into 6 3 times, so my final answer is those are my solutions. Let's do another one. Move to the homework assignments and pick one up here. I do have a question. What is this number inside here called? No, the root is right here in the V. That's the root. Discriminant. What does the discriminant tell us? Tells us the number of real solutions. For review, remember your quadratic equation is this. The discriminant is b squared minus 4ac. It's what is inside the radical. Because 3 things can happen. If the discriminant is positive, then we'll have 2 solutions. Why will we have 2 solutions? Because of the plus or minus in the front. One's positive, one's negative. If it's equal to 0, we're only going to have 1 solution. And that solution is negative b over 2a. Remember this equation too, because we'll need that in a second. So if this radical is 0, all we have left is negative b over 2a. That means you only have 1 solution. That's that. If we have 2 solutions, that means the graph crosses the x-axis at 2 points. if the discriminant is negative, it's less than 0. No real solutions. So since it says no real solutions, the graph will never cross the x-axis. So we know what the graph's going to look like by looking at the discriminant, looking at the leading term, looking at the constant. So far, so good? Let me pick one here. There we go. First off, tell me the number of solutions we're going to have. And then tell me what the solutions are. So number of solutions, use the discriminant. Negative b squared minus 4ac. 49, so we have two solutions. This is positive. Plug in the values. Negative b is -5. The discriminant is 49. We just calculated that. And there are two answers. One with a plus, one with a minus. So those are our two solutions. The next question. How many solutions? You say 2. And then the solutions are before we start doing anything, what do we have to do first? We got to move the 3 over. Has to be equal to 0. So we subtract 3 from both sides. Has to be equal to 0. Then we can fill out the ABC. So we have to subtract 3 from both sides. So the first question, we have to figure out how many solutions we're going to have. It's this discriminant. So we have b is -8 squared. A is 5. C is -3. -8 squared is 64. Positive and negative makes it a positive. 5 times 4 is 20, times 3 is 60. Greater than 0. So 2 solutions. Yes. Now we have to figure out what they are. Negative b is -8, so it's negative of a -8. B is -8 squared. 4 times A times C. 2 times A. Negative and negative makes it a positive, plus or minus. Negative 8 squared is 64. Actually, we already did that. It's right here. It's 124. This number is that. Over 10. So let's look at 124. We know that a 4 goes in there 31 times. 4 is 2 times 2. So since we have 2 2s, we can take it out. And 31 stays inside there. We've got the prime factor, whatever's inside the radical, prime factorize it. We see 2 times 2 times 31. Since they're both even numbers on top, we can take out a 2. That becomes a 4, and that becomes a 1. Everybody see where I get these numbers inside the parenthesis? Because I see both of these are even numbers, right? I know they both have to have a 2 in common. So I take out the 2, and whatever I have here, I divide by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. Now the 2 and the 10 cancel. And so my solution is that. That's what X equals. Those are my 2 X-intercepts. Getting easier. It's a lot of number crunching, plugging them in the right place and working it out. But it's just plug and play. That's all there is to it. Now, there are 3 different new types of equations that we look at. Typically, a quadratic equation is a trinomial. What does that mean? What is a trinomial? Yeah, 3 terms. What does it look like? It looks ax squared plus bx plus c equals 0. So far, all the examples we looked at, what happened? We've always looked at A, B, and C, all of them being solid numbers. The only thing we cannot have is A cannot equal 0. What if B equals 0? Now we're going to look at, instead of trinomials, we're looking at binomials. Binomial quadratic equations. They only have 2 terms. You solve using the rule of square roots. Let's look at this equation. We only have two terms. So we can use the quadratic formula. We can use complete the square, but it's going to be a lot of extra work. It's only two terms. So how do you solve this one? Separate the x's, the x's from the non-x's. Separate the x's from the non-x's. How do you get the x by itself? How do you get rid of the square? Square root, very good. You square root it because the square and square root are opposites of each other. So the square and the square root cancel each other out. And this equals a plus or minus 2. If you have this and you square root both sides, then x equals the square root plus or minus square. Why is it plus or minus square root of a? Why do I have to put that plus or minus there? No, has to do with the original equation. If I said, let's look at this. If x squared equals 4, what can x equal to make this true? I can have 2 squared, that equals 4. And then I can have negative 2 squared, that also equals positive 4. So I can take positive and negative of a number and square it, it becomes a positive 4. So whenever you square root an x squared, the answer has to have a plus or minus in front of it. How about this one? What do you do first? What are you trying to solve for? Not when we have two terms, no. Whenever you have only one term, you only have two terms, and only one term has an x, split them up. You're trying to get the x by itself. What do you have to get rid of first? The 3. How? It's not. How is it connected? Is it addition, subtraction, multiplication, or division? It's multiplication. Division would be 3 divided by x squared, or x squared divided by 3, or 3 divided by x squared. There's no sign between there. Since there's no sign, it's automatically multiplied. There's no plus, no minus, no division. So it's automatically multiplication. So since this is multiplied, to get rid of 3, what's the opposite of multiplication? Now we divide both sides. 27 divided by 3 is 9. We're trying to get the x by itself, so we have to get rid of the square. Square root both sides. X equals plus or minus square root of 9 is 3. So those are your answers. Remember, this 2 tells us we're supposed to have 2 answers. How about that one? You have two terms. It's quadratic. It's quadratic because there's a 2 in the exponent. With only two terms, how do you solve this one? Yeah, you have to move the 12 over, so you have to add 12 to both sides. So we have 4x squared equals 12. Divide by 4 to isolate the x squared. And next step. To get rid of the square, we have to square root both sides. So x is equal to what? Plus or minus the square root of 3. Because whenever I square root the squared, I have to put a plus or minus in front of it. How about this one? My first step is what? Subtract 10, because you have to separate the x's from the non-x's. Then, nope. Is x squared by itself yet? Divide by 5 to get rid of the coefficient. Next step. Square root. So what's my answer going to look like? With all the rules we've discussed so far. Plus or minus, very good. No. You got that right. Yeah, plus or minus correct.
Oh.
That's what that is, but we're not done yet. We know one thing we can change with this. You can't take a square root of a negative number. There. Because your final answer cannot have a square root inside the radical. So that's why you get the I. I know. You jump straight to the answer. And that's going to give you a very wrong answer. Okay, so that's if you have two terms. Only one of them has an x. You use, it's called the square root method. What if c is equal to 0? Here we factor. So we have two terms and they both have x's. So what can we factor out of there? What do they both have in common? 3, and what else? They both have an x. So I can take out a 3x. If I take out a 3x, what do I have left inside there? So whatever I factor out, I divide both of these by 3x. The 3's cancel one of the x's, so I have x plus 9 divided by 3 is 3, and the x's cancel. So there you have it. Are we done? No. Whenever you have an equal sign in a variable, you're not done until that variable equals something. We have two equations. So we set them both equal to 0. And solve them both separately. Divide by 3. So I have x equals 0 divided by 3 is 0. And I subtract 3. X equals -3. Those are my answers. Those are my x-intercepts. Find me the solution to that one. Okay, since they both have x's, what do I have to do with them? Well, we can, but that's not what we have to do them first. We could divide by 2 if you want to. We could divide both of them by 2. So we have x squared equals 3x. That's not a problem. Because it's a common factor, we take them out. But still, what's our next step? If we solve for x, where does the x have to be? They all have to be on the same side. So we have to subtract the 3x from both sides. So we have x squared minus 3x equals 0. Since all the terms have an x, it has to equal 0. Now we factor. What can we factor out? What do they both have in common? They both have an x in common, so I take out an x. Since I took out an x, I divide each of these by x. Whatever I have left goes inside here. X squared divided by x is x minus 3x divided by x. Then I set these equations equal to 0. And those are my solutions. So if you have two terms and they both have x's, they have to be on the same side, set equals 0, and solve from there. If only one term has an x, you separate them. That's if you have binomials. This last part of this section deals with making something into quadratic. If we have 4 terms, then we can use a method called grouping. G-R-O-U-P-I-N-G, grouping. What the grouping method says is this. I put a parenthesis around the first 2, and I put a parenthesis around the second 2. I group the first 2 and then the second 2. What can I factor out of the first one? What do they have in common? How many of them? 2 x's. So I can take out x squared. If I take out x squared, what do I have left inside there? I took out 2 x's, so I have 7x. If I took out 2 x's, I only have 1 left, 1 there. How about the second parenthesis? What do they have in common? Yeah, they both have a negative, right? So we factor out the -1, which means I change both of those signs. The objective with grouping is whatever's inside the parentheses has to be the same. We have to massage it and move it around so they're exactly the same things. Because now we have 2 terms. What do they have in common? The 7x plus 1. I can factor that out. If I take out the 7x plus 1, what do I have left? X squared minus 1. (7x plus 1 equals 0). X squared minus 1 equals 0. Subtract 1. Divide by 7. And we just work these out. These have 2 terms. It's a quadratic. Only one of them has an x. So what do we do in this one? We just did this about 5 minutes ago, 10 minutes ago. How do you solve this one? You have to get the x by itself. So yeah, so you add 1 to both sides. X squared equals 1. Square root both sides. Square root of 1 is 1. So those are my 3 answers. I'm supposed to have 3 answers because it's a cubic function. Okay, let me give you guys another one and see if you guys figure it out. Ready? There, solve that one. Okay, so we put a parenthesis on the first 2 and the second 2. Include the negative in the middle. That's part of the function. So what do the first ones have in common? X squared. They both have 2 x's in common. So if I take away 2 x's out of both of them, I got 3x plus 1. What can I take out of the second one? They both have a negative, so it's a negative 4. So I took out a negative 4. I divide both of these by negative 4 to see what remains inside the parentheses. So negative, negative makes it a positive. 12 divided by 4 is 3. X. Negative and negative makes it a positive. 4 divided by 4 is 1. So whatever you factor out to see what goes inside the parentheses, divide it. And whatever's left goes inside the parentheses. Here we have our two terms. What do they have in common? 3x plus 1. So the coefficients go in the second one. X squared minus 4. Set them both equal to 0. So x is equal to negative 1/3. X squared equals 4. X equals plus or minus 2. Those are my answers. Okay there, a little bit. The difference of two squares. This is a shortcut to factoring equations that look like this. If I have two numbers that are both squared and they're minused, I can factor those into, they're both going to be A, B. One's going to be positive, one's going to be negative. So factor that one out. Is it a difference of two squares? It has a minus, so that's check. It's a difference. The first number squared is the second number, a squared number. What is 4 made up of? 2 times 2, so it's 2 squared. Because it's a difference of two squares, I'm going to have x and 2, one's plus, one's minus. What's that one going to be? Very good. Because 25 is 5 squared. Now, why does this work? Because if we took this question here, x squared minus 25, and set it equal to 0, we'd have x squared equals 25, square root both sides, x equals plus or minus 5. Or we could do it this way. We can factor them out. X equals negative 5 and x equals positive 5. So it'll give us the same answers. It'll just write it 2 different ways. Let me see what else. Ah, yes. Let's see if you can fix this one. Find me the solutions for that one. What's the first thing you should look for? Well, no, we only use two sets if we have four terms. We only have three terms here. So if we have three terms, then we have to try to get into a quadratic form. What do they have in? Always try to factor first if it's possible. What do they have in common? They all have an x in common. So I take out one x. Now we got to solve both these. This one's pretty easy because x equals 0. That's one of our solutions. Since they all have x's, if all the x's are zeros, the whole thing's 0. So that's one of our answers. How do we find the next two? Didn't we learn three methods the other day? Factoring, complete the square, or quadratic form. Use that. Want to use one of those methods? Let's use a quadratic formula. Now, I want this to be also important for the next question I show you. You know, it's the quadratic formula is equal to x, right? In other words, you always solve for the middle term, the middle variable. So I got to label A, B, and C. And plug and play. Negative, B is -5. -5 squared. 4 times 3 times -2. So let's work it out. Negative, negative makes it a positive. -5 squared is 25. Negative times positive is negative times negative is positive. 4 times 3 is 12, 24. +24 plus 25 is 49. Square root of 49 is 7. Five plus 7 over 6 and 5 minus 7 over 6. So my solutions are 0, 2, and negative 1/3. Again, it just takes practice. You have to make sure when you see the equation, what do you notice about it? Well, this is a 3, so we're gonna have 3 answers. They all have a x, so factor out the x. This one's gonna have 1 answer, this one's gonna have 2 answers. And use methods we know so far. So this is 4, 8, negative 4, negative 8. So here's a graph. It's supposed to cross there. Find the x-intercepts, the y-intercept, and the equation of that graph. How can we do that? So what are the x-intercepts so far? Well, these are each step by 2. So this is 2, 4, 6, 8. So this one is negative 4, and this one is 2. Those are the x-intercepts. What's the y-intercept? Negative 8. Now, to find the function, the equation of the graph, we have to work backwards. I'll show you what I mean. So let's start with this. If I give you this equation, how would you solve it? Tell me what, solve for x. So what's the first thing you would do? This we could do with factoring here. What goes in the first spot? X's. How about the signs? What does the signs tell us? Yeah, they're both going to be the same. They're both going to be plus. What times what is 6? When you add them, you get 5. 2 and 3. So there's the factor of it. Now, what do we do with both of these factors? We're solving for x. Yeah, set them equal to 0. So this one's going to be negative 2. This one's going to be negative 3. So that method we know how to do. We start off with the equation and we get to the solutions. Let's work backwards. If I give you the solutions, just reverse the process. If I said that x equals negative 2 and negative 3 were my x-intercepts, I have to make these equal to 0. How do you make them equal to 0? Add 2 add 3. So x plus 2 equals 0. X plus 3 equals 0. Because they both equal 0, I know if I multiply them together, oops, that's a 3, they'll equal 0. Now I multiply them together. I got x squared, 3x, 2x, plus 6. And there you, so we have to work backwards. To solve, if I give you the x-intercepts, now we have to work backwards. So what x-intercepts do we have in here? -4 and 2. X equals -4 and x equals 2. And the next step is what? Has to be equal to 0. So I add 4 here and subtract 2 here. So x plus 4 equals 0. X minus 2 equals 0. So that's my first step. I have the x's, x equals the intercepts, set them equal to 0. Now what? Product, multiplication. I take this equation times this equation. Since they both equal 0, if I multiply them, what should they equal? If this one equals 0 and this one equals 0, then when I multiply them, this should equal 0. Now FOIL. X squared minus 2x plus 4x minus 8. Four is bigger, so it's plus 2x minus 8 equals 0. There's my equation. That's the equation, the function of that graph. Let's do another one. Here are the x-intercepts. Find me the function of that graph. Where do we start? What do we know right now about the graph? What are the x-intercepts? We know that. So when we set them equal to 0, we have to add 2 here. We subtract 2 here. X plus 2 equals 0. X minus 2 equals 0. We have to multiply them together. Now we got a FOIL. Minus 2x plus 2x minus 4. These two cancel, so they're opposite signs. There's your function. All right. Let's change things up a little bit. So we have -1. How about that one? What's the only difference between this one and the other one we just did? Yeah, it was going up. So the difference between this graph and this graph in the equation would be what? Remember, a quadratic equation looks like this. A tells us the direction. If it's positive, it opens up. If it's negative, it opens down. So this one here, it has a positive coefficient. It opens up. This one is going to, after we finish doing the work, we have to change all the signs to make it negative. Because the leading term in this one has to be going down. So we know that the X-intercepts are at those. Do it the same way. Do everything the same way, except at the very end, change all the signs. X plus 1 equals 0. X minus 2 equals 0. Let's set them equal 0. X plus 1, X minus 2 equals 0. We have x squared, -2 plus 1 is -1. It's the same stuff we've been doing. But with this equation, the leading coefficient is a +1, so this one opens up. How do we make it open down? Change all the signs. This one now opens down, so this is our answer. Because remember, our constant term is the y-intercept. It has to cross at +2. It does. It has to open down. It does. One more. How about this one? What do you think we start with this one? Remember, it's a quadratic equation, right? So we have to have two solutions. What's my x-intercept? -2. They're both -2. So if we have a quadratic equation and it just touches, that means both answers are the same. So x plus 2 equals 0, x plus 2 equals 0. Multiply them together. And work it out. X times x is x squared. 2x. 2x. X squared plus 4x plus 4. Are we done? What do you have to do? Yes, because it opens down, we have to change all the signs. And our y-intercept is -4, check. It opens down, check. Pretty good so far. All right, so that does it for section 2. There's a lot of moving parts there. And I'm not gonna lie to you, you have to practice it to get better at it. But the mechanics are all the same. All right, now section 3. 3. There's only section 3, chapter 3. Because now we're introducing to curves, no longer linear equations. Now we're talking about curves, quadratic equations, and then cubic equations, and then we're going to start building up from there. This one, we're going to analyze graphs of quadratic equations. And that's why it's important to stay current in everything we're doing, because if you stay away from it and just come in class and listen to it, it'll get confusing. When we talk about analyzing a graph, we're going to look at certain objects. The vertex. The axis of symmetry. The maximum or minimum. And there are a few other things, but we'll work with this right now. This is what we're looking at first. Since we're dealing with quadratic equations, our library of functions says that's our function. Then any horizontal movement will be noted by what happens inside the function, x minus h. Let's use b. We're used to using b. What is a? What does the leading coefficient do? It's the vertical shrink or stretch. So these are the things that we're going to deal with when we do transformations for quadratic equations. This is the form That's after you do the complete the square. You have this form right here. The vertex of this form is BC. So what would be the vertex of that equation? Remember when we dealt with circles? Anything inside the parentheses is always opposite sign. So it's going to be -3, +2. That's the vertex. We're going to shift over to the left 3 spaces and go up 2. Now, what exactly is a vertex? The vertex is the highest or lowest point on a graph. That's the vertex on a curve. If A is negative, if your leading term is negative, a maximum. Because that's the highest point. Maximum is the highest point. If A is positive, then we're going to have a minimum. That's the lowest point it can go. Now, in the function, in the parabola, that vertex, if you drew a line right through the middle of it, that vertex, you have mirror images on both sides. If you draw a vertical line through the vertex, you have a mirror image on both sides. That's called the axis of symmetry. It's symmetric about that line. How do we find the axis of symmetry? It's the x-axis of the vertex. Once you find the vertex, the x value is the axis of symmetry. So if I give you the function in the vertex form and complete the square form, then just look for those parts. But I want to work using complete the square to get that point. Now let's look at if we had, what form is this? And that's quadratic in standard form. This is quadratic formula in standard form. So quadratic function It's the function in standard form. The only thing about this is a cannot equal 0. Because if a equals 0, we no longer have a quadratic equation. We have a linear equation. Is the graph going to be any different if it's in this form? No, it's still going to be the same function. But the vertex changes. That's how you find the vertex if it's in this form. Have we seen negative b over 2a anywhere before? Right there. Because remember I said when we talked about the discriminant, if this equals 0, then we have the graph that only touches the x-axis in one point. It touches at this point. The point it touches at is negative b over 2a. That's the x value of the vertex. That's the axis of symmetry. And then once you find the x value, plug it back into the original equation, that'll give you the y value of the vertex. X squared plus 10x plus 23. We're going to find the vertex two ways. We're going to find the vertex this way, and then we're going to convert this to the other method. So what is A? 1. A, B, and C are numbers, not letters. They have to represent only the coefficients. What's B and C? So the vertex is at negative B, which is negative 10 over 2A. It's negative B over 2A. That's the formula. Two times 1 is 2. Negative 10 over 2 is negative 5. Now, according to this formula, whatever we get here, we plug it back into the function. So we have to put negative 5 back inside this function to get the y value. So it's negative 5 squared plus 10 times negative 5 plus 23. I plugged it into this equation. Negative 5 squared is 25. 10 positive times negative is negative. 10 times 5 is 50. Plus 23. 25 plus 23 is 48. Minus 50 is negative 2. There's my vertex. Once you find the X value, plug the X back in the equation, work it out, find me the Y value. Pretty straightforward. The only real calculation you have to do is the negative b over 2a. Negative b, so it's negative 10 over 2 times 1. Work it out. Let's take the same equation and convert it. Let's convert it to that equation, that form. Let's see how we do this. Take the first two terms, the X values. Remember, it has to be a 1. If there's not a 1 there, we have to factor it out. If it's a 2, we have to divide everybody by 2, and that's going to be our coefficient. That's going to be A. But since we have 1, remember when we add b over 2a, b over 2 squared to both sides? (10 over 2 squared). Since we added it, we also have to subtract it. You see what I just did there? I took whatever this b was, I divided by 2 and square it. That's complete the square method. Since I added it here, I also subtracted it, so I didn't change anything. But they go with different numbers. That's 23, not 3. So let's complete the square over here. We have x squared plus 10x. Remember, only do inside the parentheses. And this part, we work all the way out. 10 divided by 2 is 5, squared is 25, plus 23. Whatever's under the square and the first sign goes inside the parentheses. And work that out. So what's the vertex? Yeah, -5, -2. Which is what we found up here. The other way. Let me find another equation here. So it'll work, we try it both ways. Oh, I'll pick one. Let's try another one. We'll do it both ways. I'll make one up. Find the vertex and the axis of symmetry of both of these. Because we're going to do it both ways. We're going to do it in this form using the formula, and then we're going to put it into complete the square method, the vertex form. A, B, C. What's A? B and C. So the formula for the vertex is negative B over 2A. And then whatever that is, we plug it inside the equation. So what is negative B over 2A? The negative. B is negative 4. 2A is 1. So it's negative, 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 positive. 2 times 1 is 2. 4 divided by 2 is 2. So the axis of symmetry is x equals 2. That's the axis of symmetry. Once we found this value, what do we do with it? Yeah, now we go back up here and put it inside our function. 2 squared minus 4 times 2 minus 12. 4 minus 8 minus 12. Minus 8 minus 12 is minus 20. 20 minus 4 is 16, so it's negative 16. So we know our vertex is at 2, negative 16. So that's this way. That's using the formula method. Let's look at it and try to do the complete the square part. So the first thing we have to do is we have to add b over 2 squared and subtract b over 2 squared minus 12. Why do I add and subtract it together here? If I have a number, let's say 6, and I add 2 and subtract 2, what do I end up with? My original equation. So if whatever I add and I subtract, I don't change the number anymore. I cancel whatever I added. I just changed the way it looks. I didn't change the number anymore. So since I added b over 2 squared here, I subtracted b over 2 squared. So these go together and these go together. X squared minus 4x plus 2 squared. 4 over 2 is 2 squared is 4 minus 12. Whatever's under the square and the first sign. Minus 16. So the vertex is remember, it's always the opposite sign, so it's positive 2, negative 16. So what do y'all think? Is it difficult? Or just the steps are very, you have to make sure what you're doing. If you make one small mistake, it blows it up. Oh, I was gonna find some over here. We'll do that next time. Let's see what else. The applications, we'll do that next week. Well, that does it for this section. The only thing that I want to wait there, everybody else can hear, because a lot of people didn't show up today or left. The door was locked when I got here, which is ridiculous. But I want to do an example that has a coefficient. Well, let me pick one. You guys are here. You guys deserve the best. So let me give you the royal treatment. Let me find one that has a coefficient. There you go. Find the vertex and axis of symmetry. Symmetry. Because, well, let's find the vertex here the first way. This is the easy way. So A, B, C. Well, all we need to see, what is A? -2. B is 10. We don't need C really. So -B over 2A. So that's -10 over 2 times -2. -10 over -4. The negatives cancel. And we get 5 over 2. Of course, 10 and 4 simplifies. So we get 5 over 2 that way. Now, what do we do with this 5 over 2? We plug it inside the function. -2 5 over 2 squared plus 10 times 5 over 2 minus 23 over 2. So I plug this back into the original equation. Since it's squared, I square both the top and bottom. So 5 squared is 25. 2 squared is 4. Normally, we'd simplify here. But since everybody's going to have a denominator, let's not touch the denominator. Let's not simplify this one. 10 times 5 is 50 over 2 minus 20. See, so it's much easier to deal with these two. But in this first one, we can, because we want the common denominator. So -25 over 2 plus 50 over 2 minus 23 over 2. They're all over 2. 25 plus 23 is -28 plus 50. No, 48. 25, 23 is 48. So that makes it a positive 2 over 2, makes it a 1. So that's my y value. My vertex is at 5 over 2, 1. There's my answers. So far, so good. Okay, now that's one method. Let's look at the other method, the complete the square method. That's the one you guys don't like. Okay, let's look at that one. All right. Because we have a fraction over here and we have a coefficient here, we're going to use these in two different parts. So we're not going to deal with this one just yet. We're going to worry about the x's here first. We have to get rid of this -2. Whenever you factor something out, it's the same as dividing inside here to see what's left. So if I took out a -2, I simply have an x squared. Positive divided by negative is negative. 10 divided by 2 is 5x. So far, so good. Since I had to take out the -2, I take out a -2 out of both of these. If I took out the negative, I got to change the signs. And then I divide by 2. Now, inside here, I have to add the b/2 squared and subtract b/2 squared. I'm only dealing with the x's right now. I'm not touching this one just yet. X squared minus 5x (5/2 squared). That's the first part I want to deal with. Now, if I want to get this one out of there, its coefficient that -2 belongs to everybody inside the parentheses. I only want to deal with this x part here and the constant part later. Whatever's under the square and the first term. That completes the square. This one becomes 25/4. The 2 and the 4 cancel. That's 25/2. That's it. No, that was a negative. So it's going to be positive 25. Because when I subtracted, this is supposed to be a minus here. So when I separated it, still should have been a minus. And then I put this -2 in front of it. (25 minus 23 is 2/2. . So what's my vertex? Right. Yeah, I do apologize. This one is very messy. Whenever you have a coefficient, it becomes very messy. Another way, if you have a coefficient, you can split them up. I try to keep everything on one side. So in other words, forget this over here and pretend it's 0. So if it's equal to 0, forget this. Set it equal to 0, move that over there. Now it's a lot easier to work with. Because here, since I factor out a -2 here, when I add the 5/2 squared here, I have to add -2 5/2 squared here. This coefficient, whatever I do in here, it belongs to that also. (23/2). This is 25/4. Those cancel. So we have 23 minus 25/2, which is -2/2, which is -1. Whatever's under the squares and the first sign. Now I just have to add 1 to both sides. And there I have it. So there's my vertex. Yeah, we'll do a bunch more of those next time. So yeah, keep away from those right now. Keep away from anything that has a coefficient. Don't do those for homework. Skip those, and we'll do that next week. But right now, just try the other ones. They should be straightforward after that. That should finish. That finishes that section. So we only have 2 more for this chapter. Inequalities, rationals, and radicals, square roots, and fractions, and inequalities. And then we start chapter 4. Chapter 4 will take us probably a week and a half. I don't want to rush through it. We have 9 weeks left, so we're very, very well ahead of the game. So I'm really looking at if we'll slow down and we can finish a week or 2 before the semester is over. Any questions?